Well, howdy there, Internet students. We're going to start Chapter 4 today, and we're going to learn about numbers. And which you're probably thinking, yeah, it's math, so of course we're learning about numbers. But we're going to learn about properties of numbers um, and different types of numbers. Okay, so check this out. The word rational does not have the word ratio in it by accident. Rational numbers are numbers that can be written as a ratio of two integers. Okay, those numbers also have a decimal equivalent. So let's check those out. Go ahead and use your calculator. Just a reminder, to get 1/8, you're going to do 1 divided by 8 on your calculator like this. And you get 0.125. Go ahead and do the other two. You should have got numbers that look like that. Okay. Each of the fractions above can be converted, changing into decimals that have an end. In other words, the decimal number didn't keep going. It stopped right there. This one stopped there. This one stopped there. I call those terminating decimals. All right. We will need cell phones that have a calculator apps and regular calculators for this exercise. If you don't have a cell phone with a calculator app, get a calculator and pair up with a student who has a cell phone. So go borrow your parent's cell phone if you can. Use the calculator and the cell phone to change the fractions into decimal. Record all the digits that are displayed by the device. I'll show you what mine shows up for these. So here's what happens on my calculator when I do 1/3. I get exactly 10 digits of 3 on my fancy calculator. So I get, and then it ends. Now when I did this on my cell phone, it looked like this. And you can do it two ways. It says vertically and horizontally. But you can also use your calculator on your computer if you want. But 1 divided by 3 equals, and notice it goes a little bit further there on that one. So I didn't count how many there were, but if you hold it horizontally, you will get even more, I think. Anyway, check that out with your phone app, see what happens. Fill in the rest of those. So I noticed on my cell phone that the numbers kept repeating, like 7272727272 right to the end. This one is repeating like this, and then 714285, 714285, and so on. But on my calculator, check it out, when I do 5 divided by 7, notice it rounds that last digit, the 10th digit. So your calculator is deciding that I'm going to round the last digit for you. Now, if the number was below 5, then rounding it became a 3. But like on this one, the next number after this 4 is 0.1428, so that 8 rounds this up to a 3. So that's what's happening. So each of the fractions above can be converted to decimals that repeat. So when we get this, we're going to actually use this little bar to represent that, so we don't have to write all those digits out. So this means when you put a bar over it that that 3 keeps repeating. This means that this 3 keeps repeating. But you remember in that number that the 8 doesn't repeat. Okay, and this one, the 7 keeps repeating. Go ahead and do the last two for me. And that's what they look like with the repeating bar above them. Because calculators cannot display decimals that continue forever, they are programmed to either round the decimal or truncate the decimal, chop off part of it. So your computer seems to be chopping it off, and your my fancy calculator seems to be rounding it. Yours probably does too. All right, decide which of the following calculators are doing the rational numbers. So if you see that repeating thing right to the end, you're going to say it truncates it. But in this one, notice it went from a 6 to a 7, so that one rounds. Go ahead and do the rest of them. All right, those are those answers. A number belongs to a set if you can get the number by using the descriptions below. Numbers may belong to more than one set. So if it's any number that starts at 1 and goes up, like 1 and then 2 and then 3 and so on, they're natural numbers. Whole numbers start at 0 and go up by 1. So they're numbers like that. The only difference between whole and natural numbers is wholes start at 0. Integers start at 0 and they go both up by 1 and down by 1. So you get negatives and they keep going. Rational numbers can be written as a fraction and it includes terminating decimals and repeating decimals. All right, start on the left side. The first box you check all boxes that follow. So according to which number it belongs, okay? For example, 0 belongs to whole, integers, and rationals. So you're going to circle all those or box them, whatever. So negative 50, that would be in here because this one is going to go down all the way down to negative 50. So that's an integer. If you can write that as a fraction, which I can if I just put it over 1, that's the exact same thing, then it's a rational number. All right? And remember, if it's a decimal number or a repeating decimal number, for sure it's in this group, rational number. All right, go ahead and circle as many as you can for the rest of them. All right, since this is a fraction, that is a rational number. Since this is a terminating decimal number, it's a rational number, but it's not a whole number because it's not in these groups that just go up by 1. It's not in this group, not in this group either. Okay? We're going to think about these numbers. If you add two numbers in this set together, the sum must be greater than either of the numbers which you started. Okay? So we're going to circle all that work for this. Okay? So if you add two numbers in the natural set together, remember naturals are these, starting at 1, 2, 3, 4. The sum must be greater than either of the numbers which you started. Yeah, that would be true for naturals, because if you add 1 and 2, you're going to get a greater number. 1 and any number, the smallest number you can add is 1. And so the smallest you could do is do 1 plus 1. So yeah, that one works. Whole numbers, remember they start at 0. If you add 0 plus 0, you will not be greater than the number that you started with. So that doesn't work. And since 0 is also an integer, you could pick that for that. Since it's also a rational, you could pick that for that one. So nothing else works for that one. All right. I'm going to let you think about the 10 through 14, get as many as you can, and then you can check your answers. All right, here's what I get for those. Okay, this thing called a Venn diagram we can use to show the relationship between numbers. Okay, we have things called odd numbers, so those are numbers that end with a 3, 5, 7, or 9. Then we have natural numbers, which are counting numbers. They start at 1 and go up from there. So when we combine these two sets together that are odd numbers in this circle over here, so all of these four are odd numbers, and all of these four are natural numbers. There's two of those numbers that are both odd and natural. We don't include 2, so that's out here, and those are in this middle portion. They show that they belong to both sets. Okay, so which two sets could this Venn diagram describe? So think of one of those sets. You can choose from any of these four that could be on this side for set A here, this part for set B, and notice -3 is not part of either. So think about that. Here's what I came up with, and I picked whole over here because naturals don't have 0 in them, wholes do. Okay, draw a Venn diagram that shows the relationship between the integers and the whole numbers. Include at least 3 numbers in each section. So remember that numbers in here have to be both whole and integers. Now just a reminder, these are wholes. They start at 0 and go up by 1. Integers start at 0 and go both ways by 1. So they include negatives. So put 3 numbers in each of those. Did you guys notice that any number you think of that's a whole number is also an integer? So, so that would look like that. Any number you would put in this group, whole numbers, you would have to put in this middle group here. All right. Work with a partner to create a diagram with 4 concentric circles representing the natural numbers, whole numbers, integers, and rational. Include sample numbers in each of your diagram. Let me give you an example. If you put it in the natural numbers right here, like the number 1, the number 2, it has to also be a whole number because it's inside that circle also. It has to be an integer. So if you put something in here where this whole number is, if you put it in this space, it can't be a number that you would put in the natural space. So I'll give it a shot. All right, so here's what I'm thinking. That the only whole number that's not a natural is 0, so that's the only one I could think of for in here. Integers include negative numbers and whole numbers and naturals, so I just put some negatives in here because all the other ones would be in the whole and natural parts. And then rationals do not go up by 1 like wholes and naturals and integers, so I included fractions and decimals for those. Can you think of a number that can't be in any of these circles? I can. They can be any decimal number that doesn't really show a pattern but keeps going on forever and ever. And the one that I love the most is pi. Pi is 3.1428 something something something, and it goes on forever and it never repeats. Those are numbers that would not fit in any of these groups, and we call those irrational numbers. All right. Annika, Haley, and Antonio created number puzzles. Each student thought of a number and then gave clues so the other could guess the number. For problem 19 through 21, the secret number is between -10 and 10, so you only have to think of those. Okay, so in puzzle 1, my number is not, I'll do this one with you and then I'll let you try the other ones. My number is not a natural number. Okay, it's not a natural. So think of the numbers in this group that aren't natural. So you have to take out 1 through 9. My number is odd, so you can't have these even negatives now. if you add 5 to my number, the sum is a natural number. So let's cross them out. The first thing, it's not a natural, so we're going to cross out all these. And then the second thing is it's the number is odd, so we're going to cross off these evens. By the way, 0 is even. And the last thing it says, if you add 5 to my number, the sum is a natural number. So if you go 5 this way from the number, you get a natural number. So that leaves us with those two. All right? All right, you try the other puzzle, see if you can figure. All right, this one was tricky, but I decided that it needs to be a fraction with a 4 on the bottom because of this multiplying by 4. And number 21, the answer is 6. Okay, so in this set, we're going to find a number for which the statement is true. If no number can be found, we're just going to write none. So find a whole number that is not a natural number. I'll do that one with you. Remember, whole numbers start at 0 and go up by 1. Natural numbers start at 1 and go up by 1. So the only one is 0. Go ahead and try and figure out the rest of them. All right, here are my choices. And number 27, let's think about that. If a number belongs to a set of whole numbers, to which other sets must it also belong? So think about the circles. And that whole numbers were this circle here. And that circle is not necessarily part of that, the very middle, but it is definitely part of these. Okay, so since that circle is inside these two, and those were integers and rationals. All right, I think we got it there. You can go ahead and start on your assignment, and we'll talk to you soon.